Myself, Dr. Kishore Panjabrao Kadam. I am assistant professor in physics at the Arts, Commerce and Science College, RV. My specialization is the electronics. Uh, Let us start the fundamentals of the electronics, that is the semiconductor technology. First one we have to see here what is the semiconductor. There are the solid materials are the three types. First one is the good conductor, then second one is the insulator, and third one is the semiconductor. And semiconductor is defined as the which defined with respect to the conductivity, because the good conductors have the 100% have the conductivity. Insulator is approximately zero conductivity, that is known as also bad conductor. And the semiconductor has the conductivity lies between the conductivity of the good conductor and the insulator, isn't it? Now, the semiconductor has the very wide area with respect to the electronics and with respect to the era of the computer technology. And we have to define here the semiconductor, that is the two types of the semiconductor, that is the P-type semiconductor and N-type semiconductor. But before that, we have to see here in a natural form obtained with the intrinsic semiconductor. And intrinsic semiconductor are of two types, so that is are of two types of material, germanium and the silicon. That two materials are obtained in natural form, but from this germanium and silicon, that is the intrinsic semiconductor, we can perform the extrinsic semiconductor. And that extrinsic semiconductor are of two types here, P-type semiconductor and the N-type semiconductor. And P-type semiconductor means here that the material from the periodic table, that is it is the tetravalent material from the periodic table. And here the N-type semiconductor can be obtained from the material of the it is a P-type trivalent and N-type tetravalent. Pentavalent. And the original semiconductor, that is the intrinsic semiconductor, are the tetravalent, that is the germanium and the silicon. And P-type semiconductor has the positive type of the charge carriers, that is it is the 98% positive charge carriers. And here the electrons are shown in this diagram. Here it is about the 2% only. That is the majority charge carriers in the P-type materials are the holes. That is the plus signs are shown here, and negative signs are of two types, and here it is only 2%. That is it is a positive type semiconductor. Then second one is the N-type semiconductor. Here the majority charge carriers are the electrons. That is it is also about 98%, and 2% here the holes. That is it is a negative type semiconductor. When two separate P-type and N-type semiconductors are joined together here, then there will be the p-n junction diode. Then for obtain the p-n junction diode has the two electrodes. That is the first one is the positive. It has the symbol that is like this. This one positive and this one negative. This one P and N. In this way here the p-n junction diode can be obtained from the P-type semiconductor and the N-type semiconductor. Now p-n junction diode when attached in the forward bias condition, that is the positive P-type connected to the positive type battery and N-type connected to the negative type of the battery. In this case here, the current increases abruptly when we are just taking the graph between the forward bias condition. That is here the current increases very fastly, very abruptly for the forward bias condition. Now, in place of this here, say when the reverse bias condition is applied there, that is the negative type of the battery is connected to the positive type, that is the P-type semiconductor, and here negative terminal of the battery is connected to the positive terminal is connected to the negative type of the material of the p-n junction diode. Then it will be the reverse bias. Then the characteristics for that is the reverse characteristics like this. In this case here in the reverse direction, there will be the reverse saturation current flow, only that it is approximately constant, remain the constant. Approximately it is completely in the order of the micro orders, that is approximately 10 to the power minus 6. Then, but at a sudden reverse voltage, there is a breakdown occurs. Due to the high heating. Then their breakdown occurs in the two types of the avalanche breakdown and the Zener breakdown. In the avalanche breakdown here, the covalent bonds are broken, and in this way here the large current produces at a particular voltage. Similarly, in the Zener voltage also here, the large electric field obtained there, and the current increases very fastly, and there may be the damage of the PN junction diode. That is, therefore, in the reverse direction, at a particular breakdown voltage, diode can be damaged. In this way, this is the characteristics of the PN junction diode, and there are the various applications of the PN junction diode. That will be that from the PN junction diode we can prepare the transistor, we can prepare the field effect transistor, MOSFET, JFET, etc. And this is the basic, that is the fundamentals of the electronics era and fundamentals of the also computer technology also. Okay, thank you.